Okay, trig students, we're going to be learning some new trig identities for the rest of Chapter 5. The first two sections we kind of reviewed some old ones, and I guess the only new one was the even and odd identity. And then we use that to do the big things: evaluate, rewrite, prove identities, etc., etc. So we're going to do the same thing in the rest of Chapter 5, but each section has a new set of identities. Typically when I'm teaching class to class, I don't make students memorize these. I usually give them a cheat sheet, so you can have these available to you and just use them when needed. See an identity, use an identity. So be expecting that on quizzes. I'll probably maybe write the cheat sheet out, that way it's available to you, or whatever the case might be. That way we're all starting on the same level playing. So you don't have to memorize them, you just need to use them. And so the first one deals with the cosine of the sum and a difference. And so what we're doing is taking the cosine where we're adding some inputs. You can think of these inputs as being angles, as arc lengths, numbers, whatever the case might be. And it turns out, this is a common mistake. As a matter of fact, let me put it in red. So you can see that the identity is not saying that you can distribute that cosine. Right? That is a huge no-no. All right? So please don't do that. I put it in red. It's a big mistake. Hopefully by saying it you guys won't do it, because the cosine of a sum actually turns into something a little bit more complicated. It's a combination of cosines and sines, where we take the cosine of the first angle, the cosine of the second angle, and subtract the sine of the first angle, sine of the second angle. Same thing with the common mistake for students is to break that up. And again, that does not follow. All right, so please don't do that. What does follow is if you have a cosine of a difference, you're taking the cosine of the first angle, cosine of the second angle, and then adding the sine of the first, sine of the second. So there's your trig identities. The proof itself, I'm not going to worry too much about, since I'm letting you memorize these anyways. But there is a video proof of it, and I think the book also has a proof where they kind of play around. And so it's pretty good stuff to actually look at and kind of get familiar with it. But what we're going to do is just play around with our calculators and kind of experiment and see that this is true. And so what we can do is take any number, hard, easy, or whatever, and I'll work in degree mode just for simplicity at a moment. But one number that comes up to my mind is 112. All right, so we're going to look at the cosine of 112 degrees. So I'll reach over to my handy dandy, I'm using Desmos today, and so I'm going to look at, make sure I'm in degree mode, and then look at the cosine of 112, and what I get is a negative 3746. All right, so this is roughly a negative 0.37 and 46 if we round off to 4 decimals. So we know what the cosine of 112 is. To experiment with these guys, all I got to do is either take 112 and rewrite it as a sum, or rewrite it as a difference, and then we can basically use our calculators to kind of check that result. So 112, right, there's a lot of ways to break up 112 degrees. And so, one thing off the top of my head is thinking of this as 100 plus 12. All right, so there's a lot of combinations. If you don't like that one, then 112 equals 65 plus 7, carry the 1s, 47. All right, so there's lots of ways to come up with 112. So there's 2 of them. So using the identities, right, if we take the cosine of 100 plus 12 degrees, according to this identity, this is equal to the cosine of 100, the cosine of 12, minus the sine of 100, and the sine of 12. That's what that identity is basically telling us. Again, these are not common angles here, so we'll reach over to the calculator and we'll just basically test that this is a true statement. So let me clear this out. And we're looking at the cosine of 100, right? And we're going to multiply that to the cosine of 112. And then according to the identity, we subtract the sine of 100 and the sine of 12. All right, and you'll notice that the value is exactly the same as when we did cosine of 112. Again, if I switch this up and said this is the cosine of 65 plus 47 degrees, then the identity says this is the cosine of 65, the cosine of 47, minus the sine of 65, and the sine of 47. So it's an identity. This is supposed to work for all angles. So let's see if it works for this new combination. So I think if I just go through, I can switch these out. So cosine of 100 now becomes the cosine of 65. The cosine of 12 now becomes the cosine of 47. The sine of 65 using the identity, and the sine of 47. And you notice we got the same exact thing. So there's the sum. The difference is the same way. All we got to do is think of a way that we can subtract two angles and get 112. So let's think in terms of subtraction. How about we say 130 degrees minus 18? Right? So there's lots of ways to come up with 112 in a subtraction statement, but there's one off the top of my head. And so what this basically means then, following that, we're going to be using the difference identity. And so the cosine of 130 degrees minus 18 degrees is the cosine of 130, the cosine of 18, plus, right, because it's a plus sign, sine of 130, and the sine of 18. All right, so that's what the identity is breaking that down. So if you have the cosine of a difference, you can break it up as the cosine of the first, cosine of the second, plus sine of the first, sine of the second. So again, let's reach over to the calculator and let's see that in action. So I think I can continue to use what I have in there already. So we have, let me move down over here. We're now taking the cosine of 130 and the cosine of 18. That plus sign, or excuse me, that minus sign is now a plus sign, and we have the sine of 130 and the sine of 18. And lo and behold, you notice it's the same exact value that we got way before, a few minutes before. So there you have it. So there's just playing with the calculator. That's not a formal proof, okay, but hopefully it just kind of justifies that these identities seem to be doing exactly what they say. They're true for all A and B in the domain, so that makes them identity. If you're looking for a proof, like I said, I'll have a video in the module, or you can watch and kind of look and learn, or just follow what the book does. We're just going to use them. Okay, so there's your introduction to them, their truth and their values, and what not to do. Now let's go do the big things that we do, right? Find exact values, use trig identities to find exact values, rewrite and simplify, and then prove identities. So let's do that in action for these two new sum and difference identities for cosine. See you in the next video.